Now, so how are we going to use these three equations to solve a particular problem? It depends on what we have, the data that we are given in that particular problem, to know either we are going to apply the first one, or the second one, or the third one. So let's take a look at some problems and see how we can make use of the three formulas. Let's take a look at this. This one is JAMB 1996. It said a body accelerates uniformly from rest. At the rate of 3 meters per second squared for 8 seconds. Calculate the distance covered. Calculate the distance covered by the body during acceleration. So let's look at this problem. It's simple and straightforward. Just know how to apply the formulas. Now they said let's first write out the given data. A body accelerates uniformly from rest. Actually from the statement that whenever they have, if an object accelerates uniformly from rest, at that point our u is going to be 0. So now our u is 0. Now at the rate of 3 meters per second square, are they doing the same meter? That means you are referring to velocity. So they say 3 meters per second square, meaning our a is equal to 3 meters per second squared for 8 seconds. Seconds is for time. Good. So our time is 8 seconds. Then they said calculate the distance. You have to find the x, which is distance. So now the first thing to know is be perplexed that which formula are you going to apply? Is it going to be the first one, or is it going to be the second one, or is it going to be the third one? So which one are we going to apply? The first thing I will advise you, just first write out the three formula that we have, then for you to know the one you are going to apply. The first one we derive, we say v is equal to u plus at. We have another one, u is equal to ut plus 1 over 2 at squared. And there's another one, v squared is equal to u squared plus 2 ax. So now, you will now check that with this data, which one satisfies this three equation. Can we apply the first one? So let's check it together. Do we have final velocity? No. So meaning this one is not in the boundary. We cannot apply this. I hope you are following right. So can we apply the second one? Now we have to find the distance. Yes, distance is there. Do we have initial velocity? Yeah, we have it. Do we have time? Yes, of course, there's time. Do we have accelerations? Yeah, we are given. That means the second equation satisfies the condition. But let's check the third one too, if you can apply that one. Do we have v, which is final velocity? Of course, there's no v. So with that, just write, if you are solving a problem under equation of motion, the first thing is write down the three formula that you have and check that which one of them satisfy the particular data you are given for the problem. So now, let's apply the second one. We have x, which is equal to distance, ut plus 1 over 2 at squared. So here I can have x is equal to, our u that we have is 0. We are going to have 0 multiplied by the time that we are given from the problem is 8 seconds. We have 8 plus 1 over 2 multiplied by, so a that we have again is 3 multiplied by our time, it's 8 squared. You can see we are given that the value of our time is 8 squared, so that's we are going to have x is equal to 0 times 8, we are going to have 0 plus 1 over 2 multiplied by 3. 8 squared is nothing but 8 times 8. And 8 times 8, we are going to have 64. So here we are going to have x is equal to 2 here 1. You can just call this one down. 2 here 1. 2 here is 32. So 3 times 32, we are going to have 96 meter. And if you like, it depends on how you want it. You can say 1 times 3 times 64 divided by 2. You are still going to have the same result. So that means our distance here is equal to 96 meter. So let's take a look at another problem. Let's take a look at another one. But in our material, I will write like almost maybe 15 examples so that you can see varieties of how you can make use of all those formulas one after the other. Let's look at this problem. They said, question 2, a body uniformly accelerate from rest at 8 meters per second squared. They now said, in how much time will the body travel a distance of 2.5 kilometers? So what it got is, it's 25 seconds, but let's solve it also. Maybe you are going to have the same result. Now, they said a body uniformly accelerates from rest. I told you, if an object or a body accelerates uniformly from rest, it means our u must be what? Must be 0. Fine. So our u equal to 0 meter per second. So at 8 meter per second square, that means we are given acceleration to be 8 meter per second square. They now said how much time, meaning we are looking for time, will the body travel a distance of 2.5 kilometers? Which one has kilometer? That's distance. Very nice. So 2.5 kilometers. But you can see the value of this one is in kilometer. We can convert it to meter. And I told you 1,000 meters make 1 kilometer. So here I can have this one to be times 1,000. So we can have 2500. So now convert that one. So now, so let's check with the data given, which one satisfies the equation that we have? Which one satisfies the 3 equations? The first one, do we have finite velocity? No. So meaning here, the second equation to satisfy this condition, so we can still apply the second equation. So we have x equal to ut plus 1 over 2 at squared. So our distance is 2,500 equal to our u is 0 multiplied by our t, you know we are looking for t, right? So times t plus 1 over 2 multiplied by our a, we are given a to be what? 8, fine. Multiplied by, I'm looking for t squared. You can see the most important thing is just first read out the equations and look at the one that satisfies the given data. So here we have 2,500 is equal to, 0 times t, we are going to have 0. So 2 here 1, 2 here, we are going to have 4. So here we just have 4t squared. So now, since I'm looking for t, I can make my t as the subject of the formula. So divide both sides by 4, divide both sides by 4. So here we have t squared is equal to 4 in 2,500, we are going to have 625. Now, what we have here is the square. So the only thing that can cancel square is what? Yeah, square root, fine. So if I square root the both sides, and we have t is equal to the square root of 625, is going to give us 25. So that means our time is equal to 25 seconds. So let's take a look at one more example so that the one that will require for us to apply either this first equation or the last equation. Okay, let me solve one more question under that instantaneous. This is one here. They said Okay, no worries. See, in the material, I will include it, so you don't need to worry about that. To save our time, let's look at this problem. Okay, I want to find more tough questions. Let's take a look at this. Now, let's take a look at this. They said an object falls freely from a height of 25 meters onto the roof of a building 5 meters high. Calculate the velocity. Calculate the velocity with which the object strikes the roof. Strikes the roof. So this is another problem. So now let's look at this one too as well. They said an object fall freely. So that just like a come from rest. So at that point, we know normally we are going to have our u to be 0 of height 25 meter. So our height is 25 meter onto the roof of a building which is 5 meter high. You can see here, don't be confused about this. You can see we have it fall freely from a height of 25 and the roof of a building of 5 meters. So meaning the object does not reach the ground, but instead it falls on the 5 meter roof. So how are we going to do that? Just have 25 meter, then minus 5 meter that we're given. So here we are going to have 20 meter. So after that, they now said calculate the velocity. So we are looking for the v, which the object strikes the roof. So now you can see in this problem, there's one thing we are not given here. Let's take a look at the data that we have. Now, can we apply the first one? Let's check. Can we apply the first one? If I check the first one, I have v is equal to u plus 80. Do we have time? Yeah, there's no time. So since there's no time, we cannot apply the first one. At the same time, we cannot apply the second one. But let's take a look at the third case. We have v squared equal to u squared plus 2ax. Do we have velocity, which is final? Yes, we have to find the final velocity. Do we have initial velocity? Yeah, of course, we have that. Do we have distance? Yes, of course. So since we have all the requirements, we can apply the third equation. But you can see in that problem, we are not given A. If you look at data, we are not given A. But recall, I told you earlier that when we have A is also equal to G. It depends on the one you ask to use. In some situation, you ask to use 9.8 or to use 10 meter per second square. Let's say I want to take my G to be 10 meter per second square. So if I apply the equation, v square equal to u square plus 2ax. So my v is unknown, that is v squared. My u is 0, that is 0 squared times 2. Our a that we have, now a is nothing but g. I can write this formula as u squared plus 2gx. And I told you, in physics, when we have distance and height, the two are the same. Like here, this is also known as distance. As g is 10, and distance is 20. So here we have v squared equal to 0 squared That's going to give us 0. So 2 times 10, that is 20. So 20 times 20, we are going to have 400. So here we are going to have v squared is equal to 400. So now what we have is square down. So the only thing that can cancel square is for us to square root the both sides. If I do that, so here we are going to have v is equal to 20 meter per second. So it depends on the data you have in the particular problem. If you are given, maybe you may be asked to find either A or T, just look at the data and fetch out the one that's corresponding to the one that we have for the 3 equations, either the first one or the second one or the third one as well. So that's all about what we have, equation of motion. So